everybody. For today's class homework, I've chosen from section 3.10, question 10, that is asking us to find how fast the balloon's radius increases in the instance when the radius is 5 feet, and it also asks us for how fast is the surface area increasing when the radius is 5 feet. So what I did here is, first of all, I kind of need to picture what's going on in my head. So I kind of picture my balloon over here, and we have our radius over here. We also have the one piece of information that the question is given us is the 400 pi feet square per minute. So this one I'm using as the derivatives of the volume in respect of the derivatives of the time. The derivative of the volume in respect of t. I'm saying that's going to be equal to 400 pi feet cube per minute. So for the first question, we're trying to find an equation that will mix those two things. We'll mix the volume and the radius. So what I decided to use is that I was going to use the formula for the volume of the sphere. So we have the formula over here. We know that the volume of the sphere equals 4/3 of p radius cube. And then I also figure out, based on my question, what is it that I need to find. So since I'm looking for how fast the radius is going to increase, then I need to find the derivatives of the radius in respect of t, as you can see here. So the first thing that I'm going to do then, based on the formula that I'm using, that's the one for the volume, is I did the derivatives of v in respect of t is going to equal. We know that 4/3 of pi is going to be a constant, so I just need to do a quick multiplication. So what I did is I took this 3 over here and I put it in front. As you can see here, here's a 3. And then I'm still multiplying for 4p3 times r squared. And this we need to do times the derivatives of r in respect of t. And that happened also to be what I'm looking for. So let's go to the second one. So we know that the derivatives of the volume in respect of t is going to be 4p radius squared times the derivatives of r in respect of the derivatives of t. So since we know that this is what we're looking for, what I did is I took my 4p r squared and just move it to the other side. With that said, as you can see on the second step over here, I have 1 under 4p r squared times the derivatives of v in respect of t equals the derivatives of r in respect of dt. So if you remember from our first slide over here, we know that over here the derivatives of v in respect of t is going to be 400p. So I'm going to use that and just replace it over here and then divide it by 4p r squared. So taking that piece of information, I'm going to go ahead and just do p is gone, p is gone. So 4 of 400 is going to leave me with 100. And so from here, our next step is going to be 100 divided by r squared, and we know r is 5, so it's going to be 25. So this will equal 4 feet per minute. and that's going to be our answer for at least the first part of the questions. So after that, it's going to ask us how fast is the surface area increasing when R is 5. So for that, what I did, I first tried to realize what is it that I need to find. So I need to find the derivative of S, being S, the surface area, in regards of T. So I decided to choose the formula to determine the area of the sphere. So I know that the area of the surface area of the sphere S equals 4 pi radius square. So what I did after that is I took the derivatives of everything. So from S, I did derivatives of S in regards of T. Then we know 4p r squared, I'm taking this 2 and this, and just doing the regular product formula for derivatives. And since I'm doing the derivatives of r, I'm multiplying by the derivatives of r in regards of t. So if you remember, we actually already know what is the derivatives of r in regards of t based on the previous question that we just resolved. And we know it's 4. Yay! So knowing that it's 4, we can actually just go ahead and replace it. As you can see, I replace it here. We have 8pr. What other thing do we know? We know that r is going to be 5. So this is going to be 5. So pretty much we know that the derivatives of s in respect of t, it's going to be 8 times p times 5 times 4. So if we do that, that's going to give us 160 pi. And that is going to be the answer for our second question. This time I used a different way to do it. Please let me know if you guys like it better. I hope you're having a great weekend. Bye bye.